Okay, so for your prime time, I asked you to make a list or give me examples of what matter is. Okay, and I also wanted examples of what matter was not. Okay, so who can give me some examples of matter? Who can give me examples of matter? Matt. Human, definitely. Human beings, all right, beings too, are definitely examples of matter. Okay, what else is another example of matter? Key. Water. Okay, what else? Devin. Solids. Marissa. Okay, solids. Jack. Gases. And Chloe. Liquid. What's that elucid fourth state of matter? Chloe. Plasma. Good. What else about matter? Jack should know this because I saw that he had his little poster thingy out. Okay. Give me a definition of matter. You don't? It's kind of unhelpful to have that little piece of paper out there, wasn't it? Okay, what does matter take up? Space. It takes up space. And has, what does it have? Not, oh my goodness, weight is a science swear word. It is not weight, it is mass. Okay, so matter has mass. Never say weight, because we're talking about a measurement of how much matter is in an object, not how much gravity. Okay, so give me some examples of what matter is not. Give me some examples of non-matter. Sound. Excellent. Okay, what else? Chloe. Lights. Got some smarties in here today. What else? Plus, I heard it whispered in the back, too. Isabella. Okay, not magnets themselves, but the magnetic field. Okay? I heard somebody whisper. Who, was it you, Marissa? What was it? Nope, that's not it. That's not what I heard. Nick. Energy. Okay? Energy is absolutely not matter. And then we have Michael. Gravity. Look at these for a second. Gravity, magnetic field, light, sound. You guys making a connection? Okay, motion is definitely not matter. So all these things are what? They start with the letter F. Forces, okay? Forces are not matter. Forces, they don't fall in that category. So we're going to put that one up there. Okay? Now, I just want to visit real quick because you guys are actually the first class to say that air was matter. How many people are a little confused on that? Okay, and that's okay. Air is one of those things where it's like, is it or isn't it? But guess what? Air is made up of gases. So if a state of matter is gas, then it must be matter, right? Does air take up space? Absolutely. What happens when you blow up a balloon? It fills it and eventually it pops, which is proof that it takes up space. Can you move air? Really? Who said no? What am I doing? I'm fanning, okay? And if I'm fanning, then that means that air is able to move, okay? Let's see. Any other questions about what is matter and what is not? No? Okay. So this is what I want you to do. We're going to copy down the matter flow chart, okay? You're going to copy this down, and then as soon as you're done copying it, then we are going to talk about it, okay? Okay, so when we look at the definition of matter, we have matter has mass, okay? Says it right here on the flow chart. So we're going up. Matter has mass and it takes up space. That's how we know that it's matter. If it doesn't do those things, then it's not matter. Does that make sense to you? Okay. So then we go down and we have the 3 states of matter, starting with solid. Okay. Solid has two different characteristics that confirm that it is a solid. One, it has a definite shape, and one, it has definite volume. What does it mean to have volume? Okay, volume tells us how much space it takes up, or it takes up space, okay? So here we have this box of candy, right? Solid, liquid, or gas? Solid. If I threw it across the room, is it still going to be a rectangle? Absolutely. Okay, so that means it's a solid. In here are ice cubes. Okay, if I took the ice cube out, would it have a definite shape? It wouldn't have a shape? Oh, okay, so it's not like I put it on the counter and it turns into something else, right? Okay, so it has a definite shape. And if I start heating it up on the hot plate, what's going to happen to the shape? It's going to deform and it's going to turn into a liquid, okay? So we're going to talk about that in a minute. Let's talk about particles of the solid, okay? Show me what a particle of a solid would look like. Give me a solid, okay? Have you ever, boys especially, like to give me a solid, man, and they do the fist pump, right? Okay, so giving me a solid means you're going to give me a fist up in the air and act like Jersey Shore. Just kidding. Don't watch that show. It's so bad for you. Okay, so no. Okay, so if I say give me a solid, that's the same thing as the particles are combining together. They are combined together. They're tight together. Very little vibration, but they are moving just a little bit, but not a lot. And that's why they're all compact. They're uptight. Okay, so giving me a solid, that means you're uptight. And then we melt it, and then what happens? What starts happening to the particles down here? They get smooshy, okay? And yes, this is a scientific word that I invented. So you're going to, the solid particles, they start to kind of be like, ooh, I get to wiggle a little, okay? I got a little wiggle room. So a liquid still has that definite volume, okay? It takes up space. Liquid takes up space. You agree with that, yes? Okay, but what happens when I take this water and I pour it on the counter? Does it stay in the same shape that it was in the container? It does not. It goes everywhere because the liquid takes the shape of the container, okay? So that's how that works. It means it has an indefinite shape, but it has a definite volume. Does that make sense to you? Okay, how is liquid? What's that scientific word? Smooshy. Okay, it's smooshy. So you have to do smooshy. So you put your fingers together and you're kind of doing a wave like this, okay? Because that's how it's moving. It's touching each other, but it's still kind of wiggly. Not like Jell-O. It's like smooshy. Remember, smooshy. It's a Brackney. You got to remember. Okay, so we have a dictionary. I should just publish it, right? All right, so you have that's liquid, indefinite shape, definite volume. Then you get to gas. Gas is the fun part of the party, okay? You always want to, invite the gassy people because they're fun and they're all over the place. No pun intended. Okay, that's what I always say. What comes after a gas? Solid. Aha, so funny. Okay. I'm so glad that you guys get my sense of humor. That's so wonderful. Okay, but gas, we've already determined that gas takes, I'll wait. We've already determined that gas takes up space, correct? Yes, because it is matter. It's not smooshy. Liquids are smooshy. Gases, show me a gas. How does gas act? Gas is like the ADHD of the particle world, okay? He's like, woo, all over the place. So you have to show me gas. Woo! That was so weak because I'm going to tell you, if you don't do it now, I'm just going to make you come up to the front and do it with me. So show me gas, please. Woo! Michael. Oh, Michael almost got pulled up here. Excuse me. So gas has indefinite shape because it's going woo all over the place. And then it has indefinite volume because it needs a container, and the container must be closed in order for it to have a shape. Does that make sense? Okay, it's not like you breathe in cubes, right? You're not breathing in gases that are cube shaped. You might choke or something. Okay, so then we have, that's how gas is. Any question about solid, liquid, or gas right now? Okay, let's move on to plasma, because plasma is like that person that you want to invite everywhere because they're kind of crazy, but they're still kind of like fun, like gassy, but you want to take pictures of them and post them on Facebook. So this is how we do plasma, okay? You go, woo, Facebook, because they are just like the crazy person, right? You know who I'm talking about. You want to invite them to the parties just to see what they're going to do next, right? Yes? Okay. So the plasma still has the indefinite shape, just like gas. It has an indefinite volume, just like gas. So it wants to be like gas, but the only thing that makes it plasma is that it must have electrical charge in order for it to be coming to the party, basically. Fluorescent light bulbs in the ceiling. They're tubes, and they're filled with fluorescent gas. And really, all they are tubes with gas until you add electricity, and what happens? They light up. There's no wires in a fluorescent light bulb. Okay, it's just gas in there. Neon lighting. We are the neon capital of the world. Okay, and you look at the neon lights on the strip, and you have the tubes, and there's neon gases in there, and all they do is they add electricity and it glows. How many people didn't know that until just now? Pretty cool, huh? Science is cool. Yay! All right. So this is how plasma works. Okay, so it kind of tries to behave like a gas, but really it is plasma because it needs the electrical charge. Any questions about plasma? Okay. Then we get to talking about non-Newtonian fluids. These are the I don't care, I do what I want. Okay? That's what these are. Because what happens when non-Newtonian fluids, it is a liquid, technically. Okay? But what happens when what's supposed to happen when I pour water? It goes smooshy, right? See, you didn't think it was going to come back. Smooshy. So water goes smooshy because it's like, and off it goes. But if I have ketchup, for example, and I squirt that on my counter and I go, what happens to the ketchup? It forms a shape. So it's a liquid that wants to be a solid, because ketchup's bad, man. He's like the bad guy. Like, he wants to be bad. Not bad like the enemy. He's just bad. He's cool, right? What do you guys use for that? Sick. He's sick. Okay, so ketchup is like, I don't care. I do what I want. I don't have to follow the rules. Okay? He's like Jack. He thinks he can do whatever. Okay? All right. So we have ketchup, and we have yogurt and mud and cornstarch. Have you guys ever played with that goop stuff? You know, like it's water and cornstarch. You squeeze it. It acts like a solid. You let go, and then it goes between your fingers like a liquid. Okay? That's non-Newtonian. That's what that means. Any questions about this flow chart at all? Excellent. Okay, we're going to go on to the second part. Is this part right here. So go ahead and copy that down, and then we'll talk about it. Okay, so we're going to talk about phase changes, and we start with a solid. So our ice cube was a solid, right? Okay, what is the chemical formula for ice cubes? H2O, whoever that was in the back. Very good. Okay, H2O, but that was still ice, right? Okay, what happens to the ice in order for it to become a liquid? It needs to melt, and then it goes to become a liquid, which makes it water. What's the chemical formula for water? H2O. Okay, and then if the liquid continues to heat up, what's going to happen? It evaporates, which is through the process called vaporization, and then it turns into gas called water vapor. Okay, what is the chemical formula for water vapor? H2O. CO2 is carbon dioxide. Okay, so did the chemical formula change between each phase change? No, it did not. It's H2O throw. It did not go H2O, H2O, ketchup. Okay? It's still H2O. So this is what we call a physical change. It's only changing physically. It's not changing chemically. Nothing happened to the 2 hydrogen and 1 oxygen atoms as they moved through the phases. Does that make sense? This will get you every time because on a quiz, when I ask you, is changing a state of matter a physical or chemical change? You guys, your brain just wants to say chemical. This is, you have to tell it no, okay? Bad brain. It's physical, okay? It's a physical change. Not only that, it can go backwards, so the gas can cool off. Okay, so it can go the other way too. Gas can cool down and the water vapor can cool down through a process called condensation where it turns back into a liquid. And then once it cools down even more, then we're freezing and we're turned into a solid, okay? Down here at the bottom, sometimes solids will skip. It's not the time to be cleaning up at all. Okay, the solid can skip this liquid change and can go straight from a solid to a gas. And the example of that would be dry ice, because how many of you have seen dry ice? It's like frozen, it evaporates straight into a gas. Okay, that's called sublimation. All right, and it can do that backwards. For those of you who, how many people have grown up here for their whole lives, have never lived in anywhere cold ever? Okay, there is this thing called frost you may not be aware of. Okay, so when it's moist outside in the morning and the fog or the water vapor is in the sky, it will grab on, not in the sky, but in the air, and it will grab onto, grass or plants or whatever, and it's cold enough and it will immediately freeze. So it'll go from gas to a solid, and that's what we call frost. And snow also. Okay? Any questions about phase changes? All right. If you have any questions, make sure you ask me and I will help you later in class, okay?